This video is section 3.2, Domain and Range, part 1. In this section, we will find the domain of a function defined by an equation, and we will graph piecewise defined functions. The first thing is find the domain and range of this relationship, then determine whether the relationship is a function. Well, the domain is the x values. So the x values are as such. Now, normally, it doesn't matter what order you put them in, but traditionally you just put them in ascending order. That would go in there. Okay? Now, there's 4 x's, and every one of them is a distinct x. There's none that repeat, so therefore it is a relation, or this relation is a function. Now, let's look at the range. I have highlighted the range, the y values, with green. Notice that all of them are the same, and that's okay. So the range is -3. All right. So let's look at the next problem. Give the domain and range of the function. Well, I always ask this for domain. How far to the left does it go? So I come over here and I go, boom, it goes to 0. Now, is that point a solid dot or an open dot? Well, it's solid, so it gets a bracket. Now, how far to the right does it go? It goes all the way over here to 4. Now, is that point a open dot or solid? It is solid, so the domain is from 0 to 4. All of the x values that are in this particular graph is between 0 and 4, including 0 and 4. Now, let's look at the range. Okay, how low does it go? So I'm looking up and down. It goes to 0, right? 0. Now, is that an open dot or closed dot? Well, that is a closed dot. All the way up to who? Well, the highest point is 2. So, and that's closed dot. So that is the range. 0, 4, 0, 2. It's in interval notation. Like it says, it's always smallest comma largest, and it's either parentheses or bracket. Bracket includes, parentheses does not. Now, let's look at this one. The domain of this function, fx equals 30 over x minus 3, 33, is all real numbers. X, except for x when it's equal to. Now, it's all real numbers because of the numerators, just constant, which makes it look like a horizontal line. And the domain of a horizontal line is all real numbers from -infinity to positive. But when you have an x in the denominator, what you have is a restriction. You have something that x cannot be equal to because it would make it 0. And when you have a 0 in the denominator, it makes it undefined. So how do we find that? Well, you take the denominator, set it equal to 0. I'm going to add 33. So 8x equals 33. Then I'll turn around and divide. So x can't be equal to 33/8. Okay? That is the restriction. Because if I were to plug 33/8 in here, I'd get my I'd get my 8's to cancel, so that's 33 minus 33, which is 0, and you can't have 0 in the denominator, okay? So, find the domain of the function fx equals x, or the square root of x cubed minus 3x. What's the least value of the x in the domain? Okay, so a square root function, its domain is x is greater than or equal to 0. Okay, that's the basic square root function right here. But you can tell we've got stuff that's being done to this. So what we're going to do is we're going to take the radicand, which is everything in there, and we're going to set it equal to greater than or equal to 0. Okay, now we're going to solve this. You go, well, how are we going to solve it? Well, we're going to GCF it. So we're going to pull an x out. That's going to be x squared minus 36 greater than or equal to 0. You should see that this is called a difference of squares. It's a quadratic term and a constant. It's a difference of squares. So what that's going to give me is going to give me x x plus 6 and x minus 6 greater than or equal to 0. So I have x is greater than 0, x plus 6 is greater than 0, x minus 6 is greater than or equal to 0. So, and I solve them. So x is greater than or equal to negative 6, x is greater than or equal to 6. So I have all of these. Okay, x has to be greater than 0, x has to be greater than or equal to negative 6, and x has to be greater than 6. Well, those are all values. What is the least? The least is this, negative 6. Okay? All right. So let's look at this one. What is the domain of the function, following function? All right, so we're going to find the domain, and then we're going to find its restriction. The domain is going to come out of the numerator. So we know that's a square root function, which is x is greater than or equal to 0. So what we're going to do is we're going to say x plus 7, set it greater than or equal to 0. So we'll minus 7. So x has to be greater than or equal to negative 7. Okay? Now, let's look at x minus 2. We'll set it equals 0. We'll add 2. X can't be equal to 2. All right? So if we look at this, we got negative 7. That's solid. Okay? And we've got 2. That's an open dot. So it's good up to there and then past it, right? So it's negative 7 on the above, but does not include 2 because that would make the denominator 0, right? So here's what we've got. Bracket negative 7 to 2. Use a parentheses, that's an open dot. U, because we have a break, and then 2 to infinity. Okay, so what this part gets us here, and that second part gets us there. Okay, so that's how you find the domain of a function. Okay, one more, and we'll be done with part 1. Find the domain and range of this function below. Well, first off, we know it is a linear function, right? So the domain of a linear function, it doesn't matter what the linear function is always all real numbers. It's from negative infinity to positive infinity, right? Here's the symbol for all real numbers. Any x value works in a linear equation, okay? And the range, if you think about it, a line is like that, right? Linear equation forms a line. And a line goes forever down, and it goes forever up. So it is also negative infinity to positive infinity, right? Which would also be all real numbers. Okay, so this concludes section 3.2, Domain and Range, part 1 video.